Today we're going to take a look at the spaghetti sort algorithm. Now, spaghetti sort is a theoretical sorting algorithm that can sort uh, an array of items in O(n) time, um, and do so uh, in a manner that uses a parallel processing, um, and will basically sort the array uh, quickly and efficiently. Now, the theory behind it is if we compare, or if we want to think about this or manifest this in a way in the physical realm, and that's basically what this kind of simulates, is you would take spaghetti of differing lengths, and in a loose hand, you would lower the spaghetti to the table. And when the spaghetti reaches that terminal point at the table, the strands will shape themselves in such a way that when you lower your other hand down to the top, at each strand that it touches, it will that is the strand that needs to be moved into the new array being formed, and will be moved in sorted order. So, what I've done is I've mocked up a similar sort of idea uh, using what I know about O(n) sorting methods, and I've created a simulation of spaghetti sort. So let's go ahead and go through this. Now, spaghetti sort takes in an array, and in this instance, an array of numbers. And if the array is empty, it will return the empty array, the sorted array. However, if it's not, it's going to have to simulate a table, and that's what the min value is, and that's where the spaghetti would reach the table. And size, and this is the number of items in the hand. Well, theoretically in the hand. What it basically does is find a range from the maximum number in the or length of the spaghetti rod, um, and will create spaces available for, or that loose hand for sorting that array. Then, in order to simulate lowering the spaghetti down, I create a series of buckets. Each of those buckets has nothing in it, but this will simulate the spaghetti filling those spaces between the table and the tallest array or tallest rod. And then it will place each of those spaghettis into its own separate bucket um, or length, and then that is the lowering to the table. Then we simulate the lowering of the hand. So we count down to 0, so that would be at the minimum at the table, and we create a sorted array that is empty at this point. And then we take the highest rod, or the longest rod, and that's our starting point where our hand meets that lowest rod, and it pushes it, or I'm sorry, it unshifts it into that empty array with each movement down. So if we have two strands that are the same, it will hold there until those strands are moved down, and so on and so forth. Then we finally return the sorted array. Let's go ahead and take a look at that real fast. So if I want to run the method, I would go ahead and run okay, and as we can see, we get the unsorted array and then the sorted array. Now notice with the unshift, the larger spaghetti rods go toward the end of the array, and the smaller spaghetti rods go to the smaller area of the array. Okay, so then we need to go ahead and run the RSpec, and as we can see, it passes all of the examples, and that'll do it for spaghetti sort. If you have any questions, please feel free to ask them in the forum, and I'll answer them as soon as possible. Thank you.